So now it's time for triple integrals. I know that you love integrals. Double integrals, twice as much fun. Triple integrals, you guessed it, 3 times as much fun. For example number 1. Suppose that you have a rectangular box. For example, sorry about that glare. That is a rectangular box. Well, almost. Rounded corner. Thanks, Steve Jobs. Oh, here's one that doesn't have rounded corners. There you go, that's a rectangular box. And then this rectangular box measures 2 feet by 3 feet by 4 feet. And then find the volume. Of course, we could do this with 3rd grade math. 2 times 3 is 6, 6 times 4 is 24. The answer is 24. But that's too boring. Let's use triple integrals. So here's the x, y, and z axis. And then I'll put this is x, y, and z. So on the x-axis, go out by 2. On the y-axis, go out by 3. And for z, it's going to be 4. And then make what looks like a rectangle. And then this one needs to be parallel to the y-axis. Okay, anyway, so you make this rectangular box. Pretend those meet right there. Somebody squished my box right there. Anyway. So then you could do a triple integral. So triple integral, and then if you put dx, dy, dz, then what that means is you've got this whole box divided into tiny little cubes. So there's a tiny little cube right here. And then the volume of that tiny little cube is dx times dy times dz. And then what this means is add up all of these boxes. The box is going to have to go in the x direction. It's also going to have to go in the y direction. It's also going to have to go in the z direction. And since we're multiplying these 3, that gives you volume. So then x is going to need to go from 0 to 2. Y is going to need to go from 0 to 3. And you might have already guessed it, but z is going to have to go from 0 to 4. And then do the antiderivative. So the antiderivative of dx will be x evaluated from 0 to 2. And because these can be separated with multiplication, you could actually do all 3 integrals at once. The antiderivative of dy will be y, which gets evaluated from 0 to 3. And then the antiderivative of dz will be z, evaluated from 0 to 4. And then that's going to be the total volume. So this one will be 2 minus 0, 3 minus 0, 4 minus 0. So that means that the volume is 2 times 3 times 4, which equals 24 cubic units. So just like they taught us in, well, maybe volume probably was done in like 6th grade. You just multiply the 3 numbers, that's what the calculus says too. Okay, so when you integrate and do a triple integral over a region R, and you only put dx, dy, dz, then that's equal to the volume of region R. But if you do a triple integral over region R, and then you put some function here, a function of x, y, and z, and then multiply with the dy, dx, dz, then what that's saying is for each one of those little red rectangles that I drew, then what you're doing is you're calculating some type of function over each one of those rectangles. So for example, it could be a body scan. So your whole body gets scanned, so it's going to have the volume. The scanner is going to go around your whole body, and then it's going to count how much oxygen there is in each place. And so in the end, it's going to add all those up, and then it's going to have the total amount of oxygen in your whole body. So this basically gives some quantity like the amount of oxygen over whatever that region is. All right, now let's do another volume one. So for example number 2, and this one could not be done in 6th grade, or at least not in my 6th grade. So find the volume bound by these graphs. So one is z equals x squared plus y squared plus 3. Also, x squared plus y squared equals 1. And the xy plane. So because we're finding volume, that means we're just going to be integrating dx, dy, dz. But the fun part is coming up with the limits. So when it was just a rectangle, you could just put numbers. But now that these are functions, you need to put functions. So to begin with, I think I want to sketch the graph. So this shape right here, that's a paraboloid. It's been shifted up by 3, and then it's going like this. And then this makes a circle in the xy plane. So it's going to make a circle. The radius is 1. And then go up from there, because this doesn't have z in it, so it's actually a cylinder that goes straight up like this. And then it's going to intersect this thing up here, and then we're finding the volume that's in here. So this is sort of like a glass of water, and then somebody put this like as a stopper on the top, pushed it down, and then how much water remains in here. Okay, so I think that what I'm going to do is I'm going to have z go first. So z is going to go from 0 at the bottom until it reaches this paraboloid. So z, let me write my little integral symbols. So I'm going to put dz first. And z is going to go from 0 until it hits this shape right here. So it's going to go from 0 to x squared plus y squared plus 3. Next, I think I'll do the y. So for the y value, it would need to go from here to here. So this would be y equals 0, and this would be when y equals, so over here, just solve for y, and that means that y is equal to the square root of 1 minus x squared. Now, actually what I should do is have it go from the negative square root to the positive square root. Or instead of doing that, because this shape is symmetric, I could have it just go from the positive square root, from 0 to the positive square root and then double the answer. Or if you like doing more work, then put the negative square root to the positive square root. And then finally for x. So now that we have x, we would basically have a little rectangle right here. And then you need to move this red rectangle from here when x is 0 until over here when x is 1. So then the last limits are just going to be numbers. So that's going to go from 0 to 1. All right, now to actually integrate this thing, what about if we change it to polar? Dot, dot, dot. New piece of paper. So now change this to polar. So it's going to be first of all, when you integrate this with respect to z, it's just going to give you z, and then you plug in this minus this. So really this part just means plug in this function right here, and that replaces the dz. Well, this is r squared plus 3. And then because we're changing to polar, it needs to be r dr d theta. And now this part is saying the circle, it's going from the circle, the back edge of the circle to the front edge of the circle. Well, if I just tell it that's a circle and the radius is 1, then r goes from 0 to 1. Which on this picture means that it would go from here, in this direction, it would go out to the circle. And then if I have that rotate around from 0 to 2 pi, then that's going to cover the whole circle. So then theta is going to go from 0 to 2 pi. Oh, and this part, the xy plane, just means that it was cut off right here where I drew the red rectangle, so it's not going to go down underground forever. So that's basically taken care of right there. All right, now that we have it all set up, it's actually going to be a pretty easy integral. We need to just multiply through by r. So that's going to be r cubed plus 3r. And then that's what we're going to need to integrate. So that's going to be r to the 4 over 4 plus 3 r to the 2 over 2, evaluated from 0 to 1. And then I'm going to do this integral at the same time. The antiderivative of d theta will be theta, and evaluate that from 0 to 2 pi. So this is going to be, when you substitute the 1, it's going to be a 1/4 plus a 3/2. And when you substitute 0, of course, that's going to be 0. And then this will be 2 pi minus 0. So let's see, this would be 6/4 plus 1 more is 7/4. And then that gets multiplied with 2 pi. So then just reduce, and it's 7 pi over 2. And since we're talking about the volume, that would be in units, whatever they are, cubed. And now for example number 3. So evaluate this triple integral. So that's like when you have a body scan and it's sensing the oxygen throughout your whole body, something like that. And then this dv means d volume, so this is going to be dx, dy, dz, or whatever order you want to put those in. The more challenging part is setting up the limits, which is actually quite often the case with triple integrals. So a tetrahedron. So that basically means, so tetrahedron means take 4 triangles, put all their edges together until it is a 3-dimensional shape. So this one is defined by 0, 0, 0, the origin, and then here's 1, 0, 0, and then 1, 1, 0. So that's a triangle that's in the XY plane. And then 1, 0 in the Y direction, and 1 in the Z direction. So this is the triangle that's in the ground. And then make this triangle, which is one of the sides, and then go straight down. And so there's the left side, there's the front side, there's the back side, and there's a bottom. So it's actually 4 triangles. Now what I need to do is I need to find the equation for this plane right here. So basically this triangle is going straight up, and then this one is at an angle, it's laying like this. So if you see the bottom triangle, I'm going to integrate over that with respect to x and y, but as I do, I need to know what z is. So I have to go from the ground up to this red triangle right here. So we need to find the equation of this plane right here. And then one other thing is, I'm going to need to know this line right here, because when I draw the red rectangle in the ground right here, it's going to go from the x-axis, and then it's going to go until it hits this line right here. Well, because this is when x equals a 1, and also this is when y equals a 1, that means x and y are equal. So the equation of this line is just y equals x. Okay, now back to finding the equation of this plane. So in order to do that, we need a vector that is perpendicular to it. It would actually be more at an angle like this, I think. A vector that's perpendicular to it. So if you take, so this red plane right here, it definitely does have that point. And out of these 4, which one does it not have? It does not have this one. And that's this one. So basically we need to make a vector that goes from here to here. So then take this one and subtract this one to create its vector. So that would just be the vector 1, 1, 0. Now take this one's vector that goes from here to here. So I'm going to go with this minus this. And then that's the vector 1, 0, 1. And then if you have 2 vectors, and you need one that's perpendicular, then take the cross product. Boy, it's been a couple weeks since I did a cross product. I used to do it every day. 1, 1, 0, 1, 0, 1. So that would be 1 minus 0. This one would be 1 minus 0. But then, because that's the j, you have to throw on a negative. And then this one would be 0 minus 1. Excellent. Now, we need the equation of the plane. So those numbers are going to go in front, 1 minus, and then I need a point that it's going to go through. So I guess the easiest would just be the origin. It has to go through the origin. So x minus 0, and then negative 1, and y minus 0, and then negative 1, and z minus 0, and it equals 0. So let's see. That's going to be x minus y minus z is equal to 0. Or x minus y equals z. So that's this red plane right there. Now set up the actual integral. So a good old triple integral. And the direction said, I want you to integrate x times y times z, and then do d whatever order you want. And since I know, I just found out what z equals right here, I'm going to do that. I'm going to do dz first. So that's going to go from the ground, 0, up to the plane, x minus y. So those limits right there basically mean, so you go from the ground right here, this white part, and then you go up until you get to the red stripes. Next, I think I'll do dy, and then that's where this information comes in. So then, good time for a red pen. So then, on the ground right here, this little white part, on the ground, the y value is going to go from here over to this line. And that red rectangle is on the ground. And then the y value is going to go from 0 until y equals x. So dy and y is going to go from 0 to x. And then finally, the x needs to range from 0 to 1. And that operation basically takes this rectangle, has a tiny one right there, and another one, until it gets to 1 right here, and that's going to be the total. So this just needs to go from 0 to 1. All right, now that we've done the hard part, now the fun part, integrate with respect to z first. So this will be z squared over 2. That gets evaluated from 0 to x minus y. Now sometimes I do 2 or even 3 integrals at the same time. But right now I can't do that because this has a mixture of x, y's, and z's. So I should just do one integral at a time, because when I do this one, it's going to put x and y information into the problem, and then I still need to integrate the y and later integrate the x. So just one integral at a time. So this part means that x minus y is going to be squared, and the over 2, I could just factor that out. And then for integrating this, you could just add 1 to the exponent and divide by 3, and then do the chain rule. Or you could multiply it out. I think it would be faster to just go ahead and integrate it the way that it is. So this is going to be x minus y over 3. We're talking about y is the variable. So if you do the chain rule, the derivative of this is a 0, and the derivative of this is a -1. So then I need to divide by a -1. And now that needs to be evaluated from 0 to x. Now when you substitute an x in there, that's going to be x minus x, so that's 0. When you substitute a 0 in there for y, then this is going to be x is cubed over a -3 minus x is cubed over a -3. And then we still need to integrate with respect to x. So that's 0. The two negatives cancel, so it becomes positive. And then go ahead and integrate. So this is going to be x to the 4 over 4. But because there was a 3 there already, that now gives us a 12 on the bottom. Evaluate that from 0 to 1. Don't forget the 1/2 that got factored out. And so when you substitute the 1, this is going to be 1/12 and then minus 0. So it's 1/2 of 1/12. So it's 1/24. And for the last example of this section, we're going to integrate z and then dx, dy, dz, or whatever order we want. So the region R is defined by this. So this is a right circular cylinder that's opening on the x-axis, and then also these planes. So let's just take a moment, graph it, and see what this looks like. So let's take a look at the graph. Y squared plus z squared equals 9. So that makes this cylinder right here. Nice circular cylinder. And then if you graph y equals 3x, that is this blue plane right here. So it's slicing the cylinder right here along this arc. And then x equals 0 is another plane. And so it makes this little rounded triangular shape. That is what we need right there. Okay, so the graph looks something like right here. The tallest that z is going to get is going to be a 3, because if you plug in 0 for y, then solving for z in octant 1, that means it's going to be a 3. And then it was that circular / triangular shape like this. And then it's going to stop when it hits the xy plane right here. Now I need to know what number this is. Well, right here, z is equal to 0. So if you plug that in and solve for y, that means that y is equal to a 3 right here. Now there's also the line y equals 3x. And so that would be this line right here in the xy plane. And so we also need to know at this point right here, what does x equal? Well, if y is equal to 3, you could plug that in right there and then solve for x, and x is a 1. So at this point, if you go over to the x-axis, then x is equal to a 1. So this if you go underneath this red thing and look at all the volume in there, that's what we're talking about. That's the dv part. Okay, so now set up the triple integral. So it's going to be triple integral. And then I think I'll do z first. So right here, I would need to solve for z. And because we're in quadrant 1, we only need the positive square root. So z is equal to the positive square root of 9 minus y squared. And z is going to go from the ground until it gets up to this red shape. So the z is going to go from 0 to the square root of 9 minus y squared. And then they put a z right there, so I need a z. And then I'm doing dz first. All right, that part's done. Next, I'm going to do dy. So what about the y value? So this is the y-axis, so I'm talking about going in this direction. But I need to be down here in this triangle that's in the ground. So that means that the y value is going to go from, at some point it's going to be right here, and then it's going to need to go to right there. Well, right here, y is equal to 3x. And right here, well, that's this value. That means y equals 3. So this would be the smaller y value, and this would be the bigger y value. So it's going to go from 3x to 3. And then finally, dx, which is just going to be numerical information, and x goes from 0 to 1. Okay, now let's actually integrate. So this is going to be z squared over 2. Evaluate that from 0 to the square root of 9 minus y squared. and then later do dy, and later do dx. So thank goodness for that square. When you substitute that in, it's going to get rid of the square root and just give you 9 minus y squared. And then when you substitute a 0, that's 0. And for this little 1/2, I'm going to factor it out. And then we need to do dy and last dx. Now because this only has y's in it, then I can go ahead and separate them. I can do the y and do the x at the same time. So for y, it's going to be 9y minus y cubed over 3. That part gets evaluated. Oh, wait a second. This has x in it, so I can't do them at the same time. Whew, that was a close one. So it gets evaluated from 3x to 3. And then we would still need to integrate with respect to x in a moment, and there would still be the 1/2 that got factored out. And then, this problem is so fun, I need another paper. So substituting the 3, first of all, that's going to be 27. That's going to be 27 divided by 3, so we'll have 27 minus 9. And then minus, when you substitute the 3x, so that's going to be 27x. Oops, 27x. And then that's going to be minus 27x cubed over 3. And the 1/2 is still factored out, and we still need to integrate from 0 to 1 with respect to x. So this is going to be 18. And then this will be minus 27x. And then this will be plus. And then that is going to be 9x cubed. And finally, integrate with respect to x. So we would have 18x minus 27x squared over 2 plus 9x to the 4th over 4, and finally evaluated from 0 to 1. So substituting a 1 means we'll have 18 minus 27 plus 9/4. And when you substitute a 0, all of those are 0. So then this is calculator, 18 minus 27 plus 9 divided by 4, and then cut that in half. But wait, there's more. Because once I turned off the camera, I realized all of this is positive. And z in quadrant 1 is positive. So if you're multiplying a positive with a positive, you get a positive. So I was searching for my mistake and I found it. See how that says divided by 2? I forgot to do that. So then I usually re-record the whole video, but since I have so many videos for 6 classes to make, I don't have time to do that. So I redid it with the 27 over 2, and then this, instead of being a negative, should have been a positive. And then you still cut it in half, so it's positive 3.375. There we go. For real, final answer.